It's not a monologue. So yeah, as I think Ashok mentioned, right? So by the way, am I audible to everybody?
Yes, yes.
Okay, good. So I work part of Intel. Right now, I'm kind of leading a team of engineers who are mostly involved in the data center and the AI. So it's more of an engineering team, but um, we are we are right now in a position where we can interact with a lot of customers in Asia and other APAC regions. So yeah, so we do have a little bit of customer exposure. And personally, what I'm going to talk about today definitely is not about Intel, right? So I'm going to talk about whatever I have learned, during my working with these customers. Maybe I'll take few examples from most India-specific stuff without the names and the confidentiality about them, right? I may take about the problem that you solved for them and what practical difficulties we had. I'm not going to talk about the machine learning model like you guys have already heard it from the professors. I think they're the best ones to teach you those. I may go around the other things that you need to take care when you go for a practical problem solving in the industry. Okay. So does it sound interesting? Then I'll get started.
Yes, sir.
Thank you. Let me share my screen and let me know if it is visible.
But I think somebody's mic is on. You can request him to mute.
Yeah, it'll be good if we can
I think
mute.
Suresh Jagannathan. I'll mute him.
Let me know if you guys can see my screen.
Yes, sir.
Yes, sir.
Okay.
It is
Okay.
visible.
Thank you. Yeah. So maybe just as a start, right? This predictive model analytics part, I think has been around for decades. Personally, I have
Can you
used.
make it full screen?
Then let me go.
F5.
Yeah. Right.
Yeah, it's good.
Is it better? Yeah.
Yeah, good to go.
Yeah. So it's then been there. Personally, I have been into this predicting analytic stuff before even I heard about much about machine learning, right? But the problem sets were a bit different. But I think we now with this machine learning algorithms that's coming in, we can solve much more complex problem with that, right? Now, a few of the things where I believe this is now is there are growing volume of data, and there is a way we can store a lot of this data today for learning the model, the training the models and stuff, right? Software framework has also it is kind of evolved. I've seen this evolution in last 10 years or more, right? Um, Now, a lot of people will talk about the use cases which you could not imagine 10 years back earlier, right? And from my personal experience, I have seen these models are used in multiple different sectors. I have worked with few of the customers who have used it for the financial, mostly the stock market analysis, right? And they have a huge volume of data. They didn't know what to do. They had been using some of those heuristics earlier in the past, but they're open to use the financial, this machine learning stuff. In fact, there are government initiatives these days to um, look at some of the tax evasion and stuff like that, and they're probably thinking about using machine learning. Retail, right? And this has been one of the things which they have been using this predictive analytics for long. I don't know. There are many of those cases which has in fact got to the legal issues. Especially in US, I can quote about an example. One of the biggest retail chain there has been but they do track the consumer behavior, right? And one of the cases where they had been tracking the buying pattern of one of the women over a few months, and suddenly they sent some of the items shipped directly to her home address with an analytics saying that there is a baby expected in that house, and that became a legal case, right? So small or big, there are the e-commerce players today has been doing this analytics for every customer. You buy an item, the next time you go to the website, they'll suggest you something else to buy, right? And the public sector part, I think there are a lot of focus on those, whether it is the government looking at the uh, the public healthcare stuff, whether it is looking at some of the diseases stuff that they use it for the COVID scenarios and whatnot. I think that's one of the sector that is used. While in natural gas, I had seen some of those customers mostly in US, which they have hugely involved, and their data sets are very exhaustive, right? Healthcare and insurance, I don't think I have to explain. That is applicable both when you go for sort of a disease prevention stuff where there are analytics which are being used for predicting if you are facing. There are a lot of startups these days. Like one of the startups that I've been talking with Niramai, right? And they've used machine learning predictive analysis stuff for breast cancers. And insurance companies definitely are gearing up to that thing to see if they can use some of the personal data to see if that person would be within the the coverage limit, or they would have to increase the premium. So their model here is to see if the person is really going to get sick in future. That is for the healthcare part. Insurance companies in the automotive sector, which are the one that gives the vehicle insurance, they are also gearing up to the fact that they can want to use some of the learning data from the cars, right? And you will see a lot of those companies are trying to get some OBD data from the cars, right? Car engine data. And then I may talk about few of the manufacturing examples. Maybe I'll go deeper into some of those and operations, right? When I talk operations here, there are a lot of those companies who has the services they provide for post sales, right? And that's where I actually first time used predictive analytics before even the machine learning arrived on some of those companies where they had put machines across India, and their turnaround time for any kind of a services call is to be into weeks, right? And I'll give some of the examples when I go to the next files. Now, from my perspective, why do we talk about predictive analytics and machine learning together nowadays? What I've seen compared to the earlier work that I has to do, nowadays, I think most of the predictive modeling, which is the heart of the predictive analytics, do include a machine learning algorithm, right? And now we may think that, oh, this is something that we train the algorithm and this will run forever. It is not the case. I have not seen many cases where there's a static models, right? Most of these models get trained over time, and initial whatever the analytics accuracy that we have, it gets improved over a period of time when you get more and more data from the from the operations, and we use those data to retrain the model. Maybe some cases I've used the federated kind of a learning where it is basically used in multiple places, and we have used the data to train the model once again to better the delivery the results. In some cases for manufacturing, we in fact started with 90% accuracy initially, whereas the factories have been expecting about 98% or 99% accuracy, and that has happened over a period of time. And the two kinds of models that I typically used for predictive analysis are classifications, where you basically, let's say in the manufacturing case that I was talking about, right? I'll take an example of that and just go deep. There are lots of those factories who will manufacture machinery parts, right? And many of those are, I'll say, medium to large kind of a company. They're not the biggest conglomerate like Tata's or this thing. They have good enough revenue, and they've been running some of those operations for years now. But they also want to optimize their margins because there's very competitive market right now. And they would say, hey, instead of using 10 people to inspect some of those parts, can I use some analytics here, right? And I'll take one of those examples and maybe we'll just go deeper into that. And then some of the regression models that I have used, like the previous one that I was talking about for the services industry, right? Where they wanted to predict some outcome as a number. So I'll just go one level below, right? So this is one of the company that provides this cooling machineries across India, right? And they have these huge installations in many of the malls in India. And if you go to the ever go to the biggest the malls basements where they have this electrical room, you will see those cooling machines being parked, and most of the time you will see more than two, maybe at least two machines there, right? They basically run this in a standby, active, and backup mode. The reason, part of the reason why they do this is because they can't think about a failure condition where the mall has to be shut, right? From the company's perspective, those machines can fail any time, right? And they don't have the service person present in every cities in India. So they have to send somebody from Mumbai, come down, see the problem, go back with the problem data, analyze that sitting in Mumbai. Okay, then bring down the machinery parts next time they come here. So turnaround time runs into weeks, sometimes months. So what they would do in some of these cases is to get the real-time data from some of those machines which has been running across the country and analyze those and make sure they provide some of the preventive services before anything fails at the customer premise. Right? And most of these examples that I'm talking look like, oh, this is something easy thing we can do. But believe me, it has taken years for us to get there where they could optimize their model. Okay, so this is maybe so. I'll rather go on practical side. I won't come back to the theory part. I'll talk about some of the stuff which are not inside the machine learning models, right? Now, but as such, machine learning itself that I have been hearing has been there for in the hype of the emerging technology hype curve for more than 6 years now, right? The first time I saw in the hype curve for the technology, I don't know if some of you follow the Gartner technology hype curve. Um, at least many of the industry partners, I know we follow it, and we just look at the technology which are in the initial stages and when it can mature, right? So I've been seeing ML right since 2015 when Gartner started predicting right here at the top of the hype curve, right? Now, if I see there are more newer methods which are coming here, some of those are talking about physics-informed AI, the AI augmented designs, quantum ML and stuff like that, right? Which is still in early days. It will take more than 10 plus years to even mature, right? So as this field gets more mature, I think we'll see more complex problems being solved. Any questions? Maybe I'm talking fast. I mean, none? Okay. So let me go to a practical thing, right? So when I start with the customer problem, I generally start with the problem statement, right? And many times it takes days and weeks to even define the problem statement. So I would start solving the analytics problem with the problem statement from the organization that I'm working with. right? Let's say in some cases, when I talked about the machinery parts, right? They would start the problem statement. Well, I need to figure out the bad machinery parts because many of the cases when I give it to my customers, about 7 to 8%, 7 to 8% of those parts are bad, and the return is very expensive for me. How do I use any sort of analytics to prevent some of those losses? That's where the problem statement starts, but then we go deeper into the data collection, right? And then we need their in-house expertise to even start. I'm sorry, is that a question? Okay, I guess it was some other conversation. Right. So once we done with the data collection, I think the other one that we do is use their in-house expertise sometimes to even label the data. I mean, from going from outside, it is difficult to say which is good and which is bad. So many a time they will have their in-house expertise, people who can share the welding sound and say, "Oh, this part is good." There are people who will just look at it and turn 360 degrees and say, "Oh, this part is okay," right? So I would use some of those learning to start labeling the good data and bad data to even get to a set of learning data that I can use for the models. And then many a times we will see there are the data that we'll get is garbage, right? It's no use. So we start cleaning the data. That takes a while, by the way, right? And then we start going for the selection of the models. What will be the best model? Many a time that I've seen, we don't end up just selecting the best model at the first time. We do experiment with few of them and then come to a particular model. Okay, this may work in this particular case because of the latency requirements or whatever it is there, right? And then next thing that starts is for training the model. And training the model, again, as I said, it's not one time that I've seen. It is taken multiple rounds of it, and it taken several months and sometimes years to even perfect it. But right now, and then I say, start evaluating the model, right? Is this the best one? Do I need to make a change? Do I need to retrain it? All of those things start, right? And then finally, when it is in a good shape, and this is where I start calling this POC is more or less done. The proof of concept is kind of um, has met the expected criteria. Then I start thinking about deploying. And between here to now to the POC finishes, I mean, honestly, it has taken sometimes 9 months to a year. Any questions? Okay, if not, let me keep going. One of the questions that you will always hear when you talk to the customers, right? Many of them do not have their own infrastructure to, or the people who will think about machine learning, AI, and stuff like that, right? They are probably more involved in their own core domains, right? First question they was asked, what is the cost of this deployment? And they're more or less they're worried about the capital cost, right? Um, what comes to their mind is I have to buy these huge machines. It will run into crores of rupees. Would I see any result end of the day? Will that improve my operation cost? Right. This is going to be more for all the enterprises. I can talk about even when you talk to some of the services or the public sector company, they will ask the same question, right? They want to see the solution working before they make a full investment. Now, and many a time I have talked to some of them. They say, "Sir, apple खरीदने से पहले खाना चाहिए." I said, yes, I understand that, but how much time they would need to get back with the investment commitment? That is something that will depend on how testy it happens to them. And one other thing that we'll have to make sure is whatever things we deploy for analytics, it is sustainable. If for year and year, if they have to have a huge manpower to look after some of those models and keep it alive, this is going to be unsustainable for them. And you talk about some of the manufacturing companies and the public sector companies, they may not even have the skilled manpower to manage some of the stuff. So, and then what you have to do is make sure we provide adequate training to some of those folks before we leave the premise with the model implementation done. So, and then that's where it's a challenging as well, because we cannot just quickly replace those people with the new set of AI engineers. Okay, so and then let's go to some of the data related issues that I have seen, right? It's easy to talk about data, but when you go to a particular enterprise, you will see the data doesn't exist in one form, right? Some may be structured. There are various other ways people store the data in a very unstructured way. Some of those will give you some video clips. Some could be in text and images, and there are many things on paper, and we have always taken some of those papers as well, converted that to image and used those data, right? And the other part that that comes in is in the organization, there are multiple departments and divisions that you will see. Who owns the data? I've got involved in some of those projects with bigger enterprises where the IT team believed it is their project. They wanted to show the operational efficiency to their management versus the factory guys saying, this is my data, right? And they manage their expectations very differently to their bosses. So I would rather start with the top level from the CEO level and see if that's the influencing that you can use to collect the right data and take some of the boundary conditions to manage it. Right. And then I'll come to the other part of it when it comes to privacy and security part of it, because some of this data at times, the factory floor guys are very adverse to. I mean, they don't want to share this data outside of their company. They just say, hey, even if you're taking the data, just keep this. Doesn't go outside of this factory. Yeah, because they think there's a competitive risk here. So we'll have to just make sure we sometimes we need to make sure that that data that they have as part of their confidentiality doesn't even leave their premise. And then, as I mentioned about the data part, it's not most of the time. It's not in a good shape. It's not curated. Our labeling needs a very high level of expertise, and going from outside, we may not even have the right level of expertise with their help. So I have sometimes used their in-house expertise to get some of those accurate data to figure out what is good and what is bad, especially in the services cases that I was talking about for the coolers, right? There are several parameters where they're looking at. The many cases, there's the electrical parameters. They're looking at some of the vibration parameters. They're looking at some of the cooling parameters, and then based on that, as well as some of the microcontroller output, and which they could only interpret, this looks good. This machine is in a good shape. But if it goes below that, so if we started plotting some time series data on that, right? And if it goes bad on after some time, that's where I think I need to go and have somebody visit them. And by the way, this is not the other things about the model accuracy, this thing, right? So this is not my data, but what I have been learning and reading some research from the venture this thing, right? They are basically saying about 87 of the model doesn't even make to the production, right? So because the model in fact relies on the data, and the data is not good, I don't think the model is going to be useful at all. So many cases, I mean, people think that the machine learning algorithm is the only thing that we need, but believe me, that's not the case when it comes. all the model that you can, whatever best model that we can come out with, I think it is the data, which quality of the data which makes it successful. Any questions, feedbacks? Okay, not, we'll keep going. Then let's come to the data protection, right? Confidential data, as I mentioned, anybody in the organization, if they think there is a competitive, another competitor which can get hold of the data and they can benefit, believe me, they will be very conservative about sharing the data with you. Especially if they think this may go to the public clouds and stuff like that, they won't share the data with you, right? Some of the privacy related cases that I can give you is for coming from mostly from the healthcare projects, right? Where we need just to make sure we don't use any of the private data for the people, whether it is name, age, sex. So most of the time we anonymize the data to start with any of the analytics. Because if it goes to somebody else's hand, it can be misused. So we just want to make sure there is no privacy information which are embedded in those data for our analytics purpose. And then most of the time they will ask a question, okay, if you're taking into the cloud, you're running these models there, what level of security and encryption that you'll use? So you'll have to use the best in class security mechanism and do the encryption 128-bit, or otherwise just to make sure that doesn't get hacked, right? This is the sensitive data, and we need to treat that with the appropriate level of security, right? And then other thing you would get asked is, how much data do you really need? Is this good enough, right? They may give you the data which basically is only needed. They'll be really sensitive about giving more than what you need. And one other question that I sometimes got is, how long do you really need this data to retain? Can you tell me after this time is not is not maintained, it should be deleted? Okay, I'll keep going since I didn't hear any questions. And then other things that I have always considered from a customer perspective is before any data that was taken out of their premise, we did ask a question: are you comfortable if we put that on a cloud, whether it's public cloud or private cloud? I had always taken a consent from the companies, right? Even if I had to train a model, I would ask, do I need to do the training in your premise, or is it okay to take it run this in a powerful machines in the cloud, right? And depending on their comfort level and the cost they can afford to make a decision, right? So that's on the training part. Sometimes on the inferring part, it's not a choice from data perspective, but it is more some of the requirements they have. Let's say talk about the real-time latency requirement they will have. If they're having a production parts which are coming out in every seconds, for us to completely rely on a cloud machine to do the inferencing and give the output in a few, in a more than less than a second time, it's very difficult to ensure, right? So I would think about putting an on-site kind of a machine where they can make sure they use the inferencing right away there within milliseconds time, right? Okay, continuing on the quality expectation, right? Since their expectations are typically higher when it comes to the final output they would expect for any kind of modeling, right? Whether it is the regression or if it is the in a classification case. they would expect it to be 99%, right? And at times it's not possible to give us an initial expectation. So based on the POC results, I would go and tell them, hey, it may be 80% right now, but as in you get more data and train the models, it may get to 99% later, and that will predict a timeline and then talk about that, right? And then get started with just the POC that we need that much of data. It gets started with that. But one other thing that I would do is every time we go for some of those qualification, I would use some of their in-house things to learn. If I said this part is bad as for my classification algorithm, or does it your manual expert say, right? And try to match some of those results and feedback the data again. Okay, so that's on the output quality and expectation setting before you get started the projects. Now, a few things on the system requirement itself, right? That generally I have gone through, and this it's not a full checklist, but I will say this is some of the guiding thing that I've been using. So let's say we'll estimate some of the compute stuff that we'll need, whether it is CPU, GPU, some accelerators that you need to use for the training the model, doing some of the data ingestion that you need to do on a real-time basis, right? And also, we'll also think about some of the control mechanism that you may have to have, because many a times it's not only just showing the indicators. They would say, "Hey, can you also take out the bad part from here?" Right? So if there is a PLC to be controlled and managed, I will also make sure this is part of the consideration to start with. The other thing that it plays a big role here is the environmental conditions, right? We can think about, especially some of the visual sort of cases. It plays a big role, the lightings and stuff like that. Many a times I've come across a problem. This is a factory floor. Things are not what is in the lab today. So if it is working in the lab, it may not even work. Some of the machines that we had put there, if you typically buy a general compute machine, it may not even work in that factory setup because of it's going to be very high temperature there. The humidity conditions are really bad. So depending on where you are going to deploy this stuff, I would think whether to go for an industrial PC or what kind of camera that you look, right? Some of those considerations will put in place, and that may also determine some of the costing part of it, right? I talked about the speed and latency part. This also would be needed to be thought about. This may, in fact, determine your machine capability or some of the sensors that you buy for cameras and stuff like that. If you need a really high-speed camera, you need to think about it. And also, if you are trying to control the stuff, you need to leave some room for the control arm to work in between. Right? And when we started deploying some of those things, one of the practical things that we had always faced was retrofitting this new stuff into existing tools that they had. Right? If there is a machine, I need to somehow figure out a way even to put a camera around or any sort of machine there. So there'll not be ideal case where you'll say, "Oh, I'll just go and put everything new, fresh." Right? This most of the cases that I've seen is a brownfield kind of a cases where you'll have to retrofit into their existing stuff. And then we'd always think about some sort of remote diagnostics for the stuff that we deploy. Because we are not there on the factory floor all the time, and neither they will have the capability to diagnose the problems if there is a thing. And even if it is a disruption for half an hour, it's a big loss for the company. So they would not be able to afford it. So if you can do some remote diagnostics on the system that you deploy, that's something that I would always think that's needed. It's in India, right? So you will still have to deal with the stuff that we have problems at hand, of the stability of the power. Many a times, if the things go down, we need to just make sure there's enough backup available, or your system doesn't need to be, manually brought up again with a few hours, few days of time. So that's something we need to plan for. And the connectivity is always an issue. All right. If you're thinking it's going to be available all the time for us to upstream the data for any of the learning part, it's not. It's not so practical. I have dealt with issues where you had to go and buy some, a SIM module and put it in the machine, but sometimes those data connection issues would go down. So if you're thinking about getting the regular data from the machine at the on-site, we'll have to think about how can even minimize the upload from the factory. So this kind of on the soft hardware configuration stuff that I just high level touching on. Let me quickly go to the software part as well, right? This is again taken from another paper I was just going through, and this is practical, by the way. So if you think in an overall analytics setup, is machine learning code is going to be the maximum? It's not. It's comparatively, if you look at it, this is how it is going to sit, right? You will have a lot of other pieces which are much bigger than that around to support the model. Okay, so on the software framework side, we generally pick up a software framework which is going to can plug in all the modules that the customer has, or you're going to develop, right? And many a times I've seen people end up choosing some sort of a message bus architecture where they have different software modules coming on to subscribe to the events or publish the events on the message bus, so that it's a single sort of an API interface where it can plug in all kinds of things that comes from a third-party company or it's developed in-house, right? We just need to make sure there's a portable across different systems. So the reason I'm talking about a little bit of portability here is today, if you're using some sort of a compute for optimizing the cost, and tomorrow we have to scale up the operations for another problem, just to make sure you don't have to rewrite the entire software again, right? Make sure something that you're writing here is portable when it comes. And many of the companies today are supporting those interfaces. So if you write a program for one particular machine with the right framework, it'll be working in another machine as well. And that's why I think some of those companies, like in fact, Intel also has been talking about one APIs and stuff like that, right? So the intention is to make sure we make software transparent to some of the hardware changes that can keep coming. And then let's think about some of the open source versus closed source implementation that you have to do. Many a times people will pull in the open source model because it's kind of ready-made, but if there are some proprietary stuff that you have to write for customers, you just need to make sure to segregate those two. Don't mix open source and closed source together. And then the model, right? I just put some link here. You can go and see once I send you the file. There are some of the thinking you'll have to do. What kind of algorithms you'll have to choose for a specific problem. There is no one single rule for that. Right, so and that will take time, and you may have to choose one or two, and then finally drill down to the one particular model that works for the best. And then let's talk about the debug framework, right? The debug framework, which basically I mentioned about the the remote diagnostic, but here some of those cases that I have used where we needed the person who is operating on those machines to even debug some of those very small sort of a cases. Oh, if you see this LED going up, just make sure you reset that part, right? If you see something, then call me up, right? So some of those practical things we'll have to make sure this will come, and we just need to manage the operations are not impacted. Right, upgradability another one. Especially if you're using any of the open source and stuff like that, your software will go for an upgrade once in a while. In fact, sometimes even for the operating system that you're using, we'll have to go for an upgrade for some security reasons or the other. And many a times we schedule that and the non-operating hours so that customer, the production line is not impacted by this. Okay, so that's on the software and hardware considerations that I would think. Another thing that will come, generally have seen customers asking after the POC is done is, um, they have not only one part sometimes, right? They have multiple problems to solve with the different kind of parts. They'll say, hey, you have done with this, can I add this as well? So it times difficult to tell them that, okay, I need to train the data once again, and that goes through the same cycle of training and inferring and some of those things, right? So what generally I would do is, before even start the problem statement, I'll try to figure out more about the machine. If there are multiple parts to be taken care, I think we should do it planning from the beginning, not again one more stage. But they may like to use the same stuff for another setups or another problem statement. So we just need to make sure, um, you do some due diligence thinking about the extension that will come later, right? Okay, now coming to some of the final output perspective. Before you signed off from any of those things, we say, we'll make sure we just an acceptable output quality for the customer perspective. That see for any of those analytics they would work on. Many times it is taken years, as I said, but we'll just make sure this is acceptable before we work out, right? Um, and then we also tell customers if there are things that we want to improve over a period of time again, we'll provision the system such a way that it can be collaborative learning to make it better. If it is 99% now, it can get to 99.998% also, right? So we just make sure the things are set up for the regular operations without much of the intervention from on a day-to-day basis from our side. Now, this is, I think I already covered it about the smooth operations that we need to make sure it is done. Reporting is another part of the problem. They would like to see some indicators on an ongoing basis. Retraining the manpower to manage this operation, that's one challenge that generally we have to do for most of the predictive model, because people who are handling those are not so-called ITT people or the AI trained folks, right? So we need to make sure they know the know-hows to manage some of the stuff. And sometimes one of the questions that they generally ask is some of this analytic stuff that we had done are not to replace somebody who's in the organization. It is just to assist them for better results, right? Otherwise, I got few times asked this human related question. So are you going to take away my job, right? So my things to the management generally has been that it is not to take away somebody's job in the company. It is just to make sure they do a better job in terms of the quality. Okay, I talked about the ongoing operations costs that you need to optimize. If there are some huge licenses fees to pay for the softwares and whatnot, there will be always question about the ROI. Okay, so and overall, there's one of the question that typically asked is, what is ROI? Or I'll put all this effort, all this money together. What is the ROI end of the day? And that ROI, somebody may measure it by end of 6 months, somebody may measure it after 3 years, right? So what's kind of the overall ROI? Should I really go for it or not? It's difficult to say at times because if somebody starts measuring the data after 6 months, I don't think that they may see the ROI immediately, right? And but if you start comparing some of the results on KPIs on an ongoing basis, what I think I have seen, and this is something in industry data IDC would say, over a period of time, I think if we say they would see an about 20 to 50% of overall investment and ROI that we'll see, right? Compared to if they don't do that, then maybe saying about 90% of return non-predictive analytics before. So this is something I generally preach, but it cannot be one rule for everybody. Right. So as I shared some of those things, I typically go for multiple phases. Right. I would start with the POC, go through some of those initial building blocks that I just put in here. Um, and the POC generally gets done in a few months' time. But I think the one that takes time is the phase two, right? It's basically how do you keep improving some of those things until it gets to a level it is acceptable. And then the next problem set of comes in: how do you scale those things to make sure it is scalable across the organization um, or the domain it is in. Okay, so far it has been monologue. I hope it has been useful. I just some few summary takeaway. Um, so if you are going for a use predictive analytics or modeling for any of the problem solving, or the business start with the problem statement, right? And how do you measure it and what data you need, right? Deploy the AI, ML and stuff, those two models are targeted only for those kind of use cases. I mean, think some of those things are very specific, as you would know from these courses. There's no generic M model that will solve all the problems, right? And believe me, one thing: the success will depend on the data. Success will not depend on the model that you choose, right? If you get better data, it definitely the success probability will be more. Right, include all the stakeholders before you do the selection, because you would need people from the organization to support your cases. That's what I said. Sometimes I start from the top to make sure I get the support from all the teams, right? And then one of the way to keep on improving is to just keep monitoring the smaller milestones to measure towards the bigger success. Otherwise, if you're thinking, oh, after 3 years you will see the end results, it may be completely disappointing for the customers or the organization that you are working with. So, guys, this is what I had, and I can take questions.
I have one question.
Mhm.
So what type of the forecasting models are used by the industries to predict the customer demands and models and softwares?
So there's no one single model read that I had used. Sometimes the people simple use some time series data also, right? So and then but if you go to the zoo that we have maintain managed that in, I can send you the link. There are multiple models that people have used for sales forecasting. There's no one single. I can give you a bunch of them.
And so
Maybe
which
if I can
soft
include, sorry.
are they using any specific software for that, for forecasting?
So okay. For the sales, most of the organization that I have seen, by the way, I have not worked with too many organizations for the sales forecasting, but at least two of the this thing I've used, they use a lot of time the Salesforce data as a data to predict.
Okay, so thank you.
Yes, any more questions? We have time, so we can take some more questions.
So can you give some more examples of predictive analytics in manufacturing and operations? Like you said that you're going to dig into deep right in some of the cases, right?
So yeah, I mean, if I dig more detail, it will basically become a customer specific part. I can give you maybe without getting their names in. Let me talk about an automotive companies. Right, these are the two-wheeler makers. So they had used some of those models for the sales forecast, in specifically in the North Africa, which is where they had used some of the Salesforce data. Right. The other one, they had used it for the supply chain management. To manufacture a particular two-wheeler, there are like thousands of suppliers they had, and they for their assembly line to predict when those parts will be available to them, they really needed some real-time data coming from different vendors, and then based on all this thing, okay, this production line can start manufacturing on this particular day, and they will anticipate the timeline, and based on that, they'll even give their timelines to their customer. So that's one thing I saw. The other one that I've seen with the same organization where many of the times they would send some of the kits, right? So when somebody manufactures and sends it to other countries, say for Africa and all that, right? And they don't assemble the whole two-wheeler together and send it. It'll be bag of parts, right? And they'll go and just in a box together, and this will all actually get assembled in that particular country. And the problem statement always they had was, I don't know if I'm shipping all the parts here. Right? Can you look at everything and just make sure it's all there? Because we do make mistakes, and the cost of making that mistake is huge. This entire thing has to come back from that country. Can you use some of those models to even inspect all my parts to make sure I send all the things, maybe one part spare, but nothing less? So the three ways I think. When you go to some of those segments, they'll give you multiple problem statements to look after. One would be in the supply chain, one will be in the sales side, another one on the production and supply side, where they'll have to make sure they're perfect. And they would not basically tell you how to solve it. They'll just tell them, this is my problem that I have. How can you help me? And it'll take time to even understand the details of the problem and get the real data, what they missed, what was the issue, and then you start applying your practitioners into those. I don't know. Does it help?
Yeah, thank you, sir. Thank you.
Thank you.
So, how about this text or content that can be used for predictive, so, apart from the continuous data part?
You are asking how did he use the text data into the training?
Yes, yes. Basically, the text, the content part means there would be something like a sentiment analysis or text analysis.
Yeah. So I think what we did, we did that. By the way, I'm not the guy who did the model work, but I've seen people using some of those as a parameter to certain things, right? They would have some of those parameters defined as, say, if it is a sentiment analysis, they will map those to a particular attribute in the numbers.
Okay,
Yeah,
sir.
I'm sorry, I may not be able to answer the model question because I'm not the machine learning guy. I'm more kind of using some of those models to solve the problem.
Okay, sir. Yes. Thank you, sir.
Okay, Ashok, I think if no other questions, I'll send across the slide. If any question comes up, you have my email ID. Feel free to send it to me, and give some time back to the people.
Okay, so if there are no more questions, then we'll end this session. Okay, fine. So post lunch, we'll join at 2. So thank you, Manoj.
Thank you, everyone. Yeah.
Yeah. For a perspective from the industry. And there are some questions, I think. What software development model used for predictive analysis?
So each of the companies will have their own software framework. Okay, if I want to get to the specific one that I had used some of those industry cases, there is an age analytics framework that I use, which is, in fact, if you go to the Intel website, you will find that as well. The short form is called EIS. Right? It's nothing but it's kind of a short message bus structure where different models and the software models can plug into that. And if you go to the some of the website for OpenVino, this is one of the APIs that we had publicly been providing. OpenVino does have some of the software models, ML models in a library called Zoo, right? And there are specific things that you can take up for your own learning. And those are open source, by the way. So, yeah. But only thing that I didn't want to do it was just to take a training on OpenView. I could have done that, but that may not help.
Yeah. One more question is there. What are the data protection policy which are present in predictive analysis? Data protection. Yeah.
So, okay, the most cases I had used some sort of an encryption to make sure whether it is cloud or cloud hosted or any other machines, the encryptions, as an OpenSSL 128-bit encryption is something that I've been always using to protect some of this confidentiality data.
Okay. Okay. So if there are no more questions, we'll end this session. Thank you once again, Manoj.
Thank you. Yeah, thank you for that.
So yeah, so we'll break for lunch now, and we'll meet. We'll again. So the meeting will continue. We'll again meet at 2 for the next session. Thank you. Thanks.
Thank you. Bye.